AI is evolving at, well, an incredible pace, isn't it? And the open source movement seems absolutely central to so much of this progress. So today we're doing a deep dive into the fascinating and, yeah, sometimes fraught world of open source AI. It's a space just buzzing with innovation, but it also brings some serious risks we really need to understand. Mission here, our goal for this deep dive is basically to unpack that core debate around open source AI. You know, the incredible innovation it unleashes versus the pretty critical risks it introduces. We'll explore some of the cutting edge models and then really dig into their real world impacts and the technical and ethical challenges we're facing.
Yeah, and what's fascinating here is how these sources give us such a panoramic view, really. You get everything from the intricate engineering that makes these models even possible, all the way to the big societal implications they carry. We'll try and connect those dots for you. Show not just what's happening, but, why it actually matters.
Okay, so let's unpack this incredible surge in open source AI that it really feels like every single day there's a new model just pushing the boundaries. What are some of the standout examples that, really showcase this innovative spirit, and how are they making AI more accessible maybe to everyone?
Well, one of the really impressive recent examples is DeepSeek V3. They're a large mixture of experts model. MOE, they call it.
MOE, right.
Yeah, think of it like having lots of specialist submodels inside, but only a few are actually active for any given task. DeepSeek V3 has this staggering 671 billion total parameters, but efficiently only about 37 billion of those get activated for each token it processes.
Wow.
And its aim is really to push those open source capabilities much closer to the leading closed source models, like GPT-4o and Claude 3.5 Sonnet. And it's not just about the raw size either. DeepSeek V3 shows really strong performance, particularly in kind of crucial areas like coding and math. When you look at the benchmarks, things like Live Code Bench, JSMAK, math, it's very competitive, often doing better than other big open source models like LLaMA 3.145B base and Qwen 2.572B base.
That efficiency is really quite remarkable, isn't it? Could you maybe elaborate a bit on the technical breakthroughs? Like, how are they getting these economical training costs and that level of performance?
Sure, certainly. A key part of DeepSeek V3's success is its economical training cost. It's only about, $5.576 million for the full training run?
That's surprisingly low for something that big.
Right. And this efficiency, it isn't just about tweaking a few parameters here and there. It's really the result of some fundamental innovations that optimize both the training and the inference when the model is actually used. For instance, they've pioneered some new methods for inference like multi-head latent attention or MLA. That helps the model process information much faster.
Okay.
And for cost-effective training, they brought in something called DeepSeek Mo. But maybe most notably, they've adopted the FP8 data format during training.
FP8?
Yeah, FP8. It basically doubles the computational speed compared to BF16, which is BrainFloat 16, a pretty common numerical format used in AI.
Yeah.
These aren't just, technical jargon. They represent a really significant leap. They make cutting-edge AI development more accessible, more affordable. It sort of democratizes access to capabilities that were once pretty exclusive to really well-resourced labs.
That makes sense. Now, beyond language models, we've seen just a revolution in image generation, too. Stable Diffusion really changed the game there, didn't it? What made it so impactful?
Oh, it absolutely did.
Yeah.
Stable Diffusion, yeah, it's a deep learning text-to-image model. It's based on diffusion techniques, and it's really a premier product from Stability AI. Its significance, well, it really can't be overstated because its code and its model weights were publicly released.
Right. That was the key difference.
Exactly. It marked a major departure from the previous proprietary models like DALL-E and Midjourney, which were mostly, cloud-based services you had to pay for. And this accessibility, it's a huge win for users, for you. An optimized version can even run on regular consumer hardware with as little as maybe 2.4 gigs of VRAM, though 10 gigs or more is definitely recommended for better performance.
Still, pretty amazing for home use.
Totally. And it's incredibly versatile. It can generate really detailed images just from text prompts, can do in-painting, out-painting, even image-to-image translations. You could feed it a rough sketch, and it can turn it into detailed artwork. Its development actually involved researchers from the Confis group at Ludwig Maximilian University of Munich and Runway, with computational support from Stability AI, of course. And the training data came from the nonprofit LAION.
Interesting collaboration. And you mentioned Qwen earlier. Qwen 2.5 Max is another one pushing the envelope, especially, I think you said, with its massive training data.
Yes, exactly. Qwen 2.5 Max is another one of these large-scale MoE models. It was pre-trained on just an enormous data set, over 20 trillion tokens.
20 trillion.
20 trillion tokens. And then it was post-trained using SFT, that's supervised fine-tuning, where it learns from human-labeled examples, and RLHF, reinforcement learning from human feedback, which uses human evaluations to sort of further refine its responses, make them better aligned. Its performance is also very strong. It actually outperforms DeepSeek v3 in some benchmarks, like Arena Hard, Live Bench, Live Code Bench, and GPQA Diamond. And it shows pretty competitive results in MLU Pro as well.
The sheer scale and performance of models like Qwen 2.5 Max, it really highlights the immense power that's now available through open source. But, okay, with such power and accessibility, there's always a flip side, right? What are the most pressing risks and maybe ethical challenges that emerge when these groundbreaking AI tools become so widely distributed?
Yeah, if we connect these to the bigger picture, I mean, the very accessibility that fuels all this innovation, it also amplifies the potential for harm. It just does. And this raises a really important question about how we ensure these powerful tools are used responsibly and equitably. So let's maybe start with bias and fairness. Bias can kind of creep into AI in several ways. I mean, human decision-making has long suffered from implicit biases, right? Think about lending racial or gender disparities in credit approvals. They've existed for decades. AI models, well, unless AI fairness becomes like a core design principle from the start, they risk just perpetuating these same biases.
Right, baking them in.
Exactly. We see this with Stable Diffusion, for instance. It mirrors biases and misconceptions that were present in its training data, the LAON5B dataset, and that leads to images that can reinforce social biases. They tend to be, from a very Western perspective, largely because it was primarily trained on images with English descriptions.
That's a really crucial observation. It highlights how deeply ingrained this stuff can be. So in practical terms, how does this bias translate into real-world impact? And more importantly, what tools are being developed to actively try and combat it?
Well, a clear case study is loan adjudication, like we mentioned with lending. Imagine a probability of default model, right?
Right.
It might reject male applicants more often, even if they're creditworthy. That's a higher false positive rate. Or conversely, it might approve female applicants at higher rates, but then they might struggle more with repayments. That's a higher false negative rate.
So unfair outcomes either way.
Right. In one baseline model they looked at, there was actually an 8% gap between groups in what's called equalized odds difference. That's a metric that checks if the error rates are fair across different groups. Now, to combat this, there's the open source Fair Learn toolkit. It's a Python toolkit from Microsoft, actually. It's designed specifically to assess and mitigate these fairness-related harms. It focuses on group fairness, using metrics like demographic parity, which aims for similar outcomes across groups, and equalized odds, which focuses on ensuring fair error rates, like we just talked about.
Yeah.
And by applying Fair Learn's mitigation tools, things like Threshold Optimizer and Grid Search, a team was actually able to cut that equalized odds difference down to just 1%.
1%? That's a huge improvement.
Massive improvement, yeah. And while maintaining the overall accuracy of the model. And there are other valuable tools out there too, like IBM's AI Fairness 360 and Aequitas.
So it really sounds like ensuring AI fairness requires looking beyond just the algorithms themselves. It's the whole life cycle, the broader societal context too.
Precisely. It really is what they call a socio-technical challenge. It demands transparency. It needs ethical oversight, which means working with legal experts for compliance, for example. And it requires continuous monitoring of these models because societal norms change, data drifts. The good news, though, is that these tools show that AI fairness doesn't have to come at the expense of performance. You can often have both. Now, moving on to privacy and security. The open nature of model weights, the code bases, the data sets, it brings its own set of worries. For example, those LAION data sets that Stable Diffusion was trained on, they've raised flags because they potentially contain large amounts of private and sensitive data scraped from the web.
Right. I remember hearing about that.
Yeah. And similarly, DeepSeek v3's open source nature means its technical architecture, like the MLA, DeepSeek Mo, the FB8 training, and its training processes, are all openly detailed. Now, for some models, this kind of transparency could potentially raise security considerations in other contexts, because the inner workings are just publicly visible.
Makes sense. And given how powerful these tools are, there's also just the straightforward concern about malicious use, right? Deepfakes, misinformation. How are developers trying to manage that? Or is it simply sort of out in the wild once it's open source? Is the genie out of the bottle?
That's a huge concern for sure, a really significant one. There are definitely acknowledged risks of, well, malicious use of generative AI tools and deepfakes, especially given Stable Diffusion's, let's say, permissive nature in content generation compared to more controlled commercial products. It's been noted that pretty much any restrictions Stability AI might try to place on the content users generate, well, they can often be easily bypassed because the source code is available.
Right. Someone can just modify it.
Exactly. Now, in terms of governance, there have been attempts at self-governance, mostly through licensing. So before Stable Diffusion 3, it used something called the Creative ML OpenRail M license. And that explicitly prohibited certain use cases, things like crime, libel, harassment, doxing, exploiting minors, giving medical advice, creating legal obligations, or discriminating against groups.
Okay, so some guardrails were attempted.
Attempted, yes. The current Stable Diffusion 3.5 uses the, quote, permissive Stability AI community license, quote. Though commercial enterprises with over $1 million in revenue, they need to get an enterprise license. But crucially, under both licenses, the user actually owns the rights to their generated output images, and they're free to use them commercially.
That's interesting about ownership.
It is. And Stability AI CEO, Imad Mostak, has been quite clear on his stance. He stated that, quote, it is people's responsibility as to whether they are ethical, moral, and legal in how they operate this technology. His belief is that open availability would lead to a net benefit overall by ending, corporate control over these kinds of powerful technologies. However, there are also ongoing legal challenges. There's the Getty Images versus Stability AI lawsuit in the UK concerning copyright law. That's expected to go to trial in summer 2025, and it could have really significant implications for how we understand AI-generated content and ownership moving forward.
Yeah, that'll be one to watch. So bringing it all together, what does this all mean for us, for you listening, as learners, users, just people navigating this really rapidly evolving landscape?
Well, I think we've seen how open source AI is truly, genuinely democratizing access to cutting-edge technology, right? It's fostering innovation at just an unprecedented scale. But at the same time, it's simultaneously presenting these significant ethical and safety challenges that the community is actively working to address, it's important to say. The integration of fairness tools like FairLearn, hopefully right from the very start of AI development, the ongoing efforts in responsible licensing, and the continuous push for more robust and efficient models like DeepSeek v3 and Qwen 2.5 Max. These are all part of this really vital, evolving conversation. Ultimately, it's about building trust and trying to ensure that these incredibly powerful tools serve society equitably.
And as these models continue to scale up in size and intelligence, I mean, you mentioned researchers even exploring how they might transcend human intelligence. That was a phrase used to describe Qwen 2.5 Max's future direction, wasn't it?
It was, yeah. Quite a phrase.
It really makes you wonder, doesn't it, how much of this responsibility really lies with the creators and how much is now truly in the hands of the global community, the users, the developers, everyone. What will you build with it? Thank you for joining us on this deep dive into open source AI. We really hope it's given you a clearer picture and maybe some new questions to ponder.